Throughout the course of this semester, you're going to see many examples of mass-to-mass calculations, where you have to calculate the mass of something, some chemical or a molecule, atom, something like that, from the mass of some other chemical entity. So I want to show you the basic process that you have to use when doing these mass-to-mass calculations. Now, a lot of these will be involving chemical reactions, but since we haven't gotten into chemical reactions yet, this example I'm not going to give you now does not involve them. However, you're going to be using the same basic process even when we are doing mass-to-mass calculations involving chemical reactions. So for this problem, we're going to say how much P2O5 contains 1.0 times 10 to the third grams of phosphorus. So I'm saying here that we have a sample of P2O5. And if you want, you can try naming that. I want to know if that sample has 1.0 times 10 to the third grams of phosphorus, how much does the entire sample weigh? Alright, so can we do some kind of conversion directly from the mass of phosphorus to the mass of diphosphorus pentoxide? The answer is no. Unfortunately, you cannot directly relate the mass of one component to the mass of another. The only thing you can relate is moles. So, remember, moles is going to act kind of as like the hub of many of our calculations throughout the semester. So, generally speaking, if you are going from the mass, if you're trying to do a calculation, mass of A, and A is just any generic species that you're starting with, to the mass of B, which is just any generic species that you're looking for in your answer. Again, you cannot do that directly. Instead, the process you have to take is a little bit longer. You have to go from the mass of A to the moles of A. And remember, between mass and moles, you're going to be using molar mass. Then, now once you're in moles, you can do a mole-to-mole ratio to get into moles of species B. And then you can use the molar mass of species B to finally get back to the mass that you're looking for. So let's do that with this problem as an example. So we're starting with 1.0 times 10 to the third grams of phosphorus. So I'm going to put this over 1 just to try to make it still look clear. So if we're trying to cancel out the units of grams here, and the grams is in the numerator, that means that we need to put it in the denominator so it can cancel out. Because remember, anything divided by itself is 1. So by default, that means moles has to go in the numerator, because remember, we're doing this first step where we have to use the molar mass of phosphorus. So the molar mass of phosphorus, you can get from the periodic table, is 30.97. I'm going to cross out the units of grams, so now we're in units of moles of phosphorus. Now, we need to use the mole-to-mole ratio to go from moles of phosphorus to moles of P2O5. What is the mole-to-mole ratio? Well, let's just look at the formula of the molecule. P2O5, for every single molecule of P2O5, how many phosphorus atoms do you have? You have 2. That's what that subscript means right there. So that means that if you have 2 molecules of P2O5, you have 4 phosphorus atoms. If you keep going, that would eventually mean that if you have 1 entire mole of P2O5, you would have 2 moles of phosphorus atoms. That is your mole-to-mole ratio. So now we need to cancel out the units of moles of phosphorus, so that has to go down here, which means moles of P2O5 goes up in the numerator. So we just said for every 1 mole of P2O5, you have 2 moles of phosphorus. So now we're here, moles of species B. So now we can use the molar mass of species B, which is P2O5 in this case, to get back to the mass. So now we're trying to we have to cancel out the units of moles to get back into mass. So now moles has to go in the denominator this time. So be careful. The first time we had to divide by the molar mass. This time the molar mass is going to is going to be in the numerator. So it's 283.89 for 1. Those units cancel out. And the only unit we're left with is grams of P2O5, which is exactly what we want. And that, again, now you just multiply all your numerators across, multiply all your denominators across, and divide. It gets you an answer of 4.6 times 10 to the third grams of P2O5. And that's your answer. And that's, again, how you're going to do just about any mass-to-mass calculations that you see throughout the semester. You always have to get into moles first, then do a mole-to-mole ratio, then you can go back to mass.